The subject of my paper is compile-time computations with subtyping. We say that type T1 is a subtype of type T2 if every object in T1 is also in T2. For example, here we have class A and class B that inherits from A. So we can assign a B to a variable of type A because every B is a kind of an A, or we say that B is subtype of A. We also have subtyping in type arguments. A list of B's is a collection of B's. But is a list of B's also a list of A's? Let's see. The answer is no, and the opposite is also not true. Let's delete this. Sometimes we do want subtyping in type arguments. For example, if we have a read-only list, then a read-only list of B's is a read-only list of A's, because every B we read from the list is also an A. To implement this behavior, we specify that the type parameter of the read-only list is covariant. In C#, we do so by writing out before the T. And now the code compiles. Likewise, a write-only list of A's is a write-only list of B's, because we can write B's to a list of A's. This is a contravariant behavior, and in C# we implement it by writing in before the type parameter. Great. In my paper, I investigated the subtyping machine, which is a program that uses subtyping to carry out computations at compile time. Here, for example, we have a subtyping machine that computes palindromes. So this is the subtyping machine. And we can run the subtyping machine by writing down a variable assignment. The variable assignment invokes the subtyping algorithm. You can see that variable palindrome compiles correctly because its variable type encodes a palindrome. If we make this word not a palindrome, then the assignment does not compile. And if we fix it into a palindrome again, then the code compiles. In the paper, I also introduced treetop. Treetop is a C# source generator that compiles context-free grammars into subtyping machines. Using treetop, we can embed domain-specific languages in C# as Fluent APIs. For example, let's say that our DSL is the language of balanced braces. So this is the context-free grammar that defines the language of balanced braces. A balanced braces is a balanced braces followed by a balanced braces, or an open parenthesis and then a balanced brace followed by a closed brace, or of course the empty string. Treetop automatically compiles this grammar into a Fluent API of the domain-specific language. Now we can invoke this Fluent API by calling its methods in Fluent style. So here we can call open, open, close, close, which is a sequence of balanced braces. And this code compiles correctly. Let's run it. Great. If the method invocations is not a balanced braces, so if, for example, we close a missing brace, then the code does not compile. And the compiler generates a compilation error.